Good afternoon, everyone. How are you doing? How is everyone doing today? Good afternoon, Anastasia. I hope you all are having a good week so far. I know the week is almost coming to an end, so I hope you've enjoyed your week so far. So today we're going to have a good time. I'm going to focus on topics that are ranging from about 8th grade, and I think I'll probably do some geometry as well. Maybe one or two questions that are geometry based. So I'm looking forward to having a good time with you all. There are going to be two puzzles, one puzzle after a few questions and another puzzle toward the end. So feel free to participate in any question. I'm not going to put any grade so that you don't feel obligated to answer one question or not answer another question. So this is open to everyone to make an attempt at it. So let's go ahead and just wait for a few more seconds for some to join us, and then we will get started. All right, so we can get started. Thank you all for joining. If you're here with us for the first time, please go ahead and subscribe to the channel, like the video. We're going to do a lot of math problems today, as well as have a good time with puzzles. So we're going to get started right away. Looks like we have quite a good number already in our audience. So let's go ahead and get started. Remember, the way that we're going to walk through this is I'm going to put the question up there, I'm going to give you some time to try to answer them. If you don't have a clue, or you don't have an understanding, or you don't have an idea, or you've never seen this before, be patient. We'll get to solving it together, and then you can ask questions. Always remember that this is a safe environment for you to ask any questions. So we're going to get started with our first question, and let's get the boat rolling. So first question here is going to be about slope. What I've tried to do also is I've looked at in our summer program, I'm looking at the 8th to 12th graders and what they're studying, and I'm also using this as an opportunity to highlight those topics. So if you see any topics here that you're covering that we're not talking about, please highlight them and we'll be able to get into those topics as well. Or if you're not in our summer program and you want to ask a question about any math topic that you're struggling with or that you have questions about, feel free to ask as well. This is an open forum for everyone to learn something, to gain something from. Geometry, okay. Michelle, good afternoon. Thanks for joining us today. We will have some geometry topics. Do you have any specific geometry topic that you want us to look at? So a lot of what we have here is going to be algebra. There's some algebra 1, algebra 2, and 1 or 2 geometry questions, but every topic here can be applied in some way to geometry. For example, this topic that we're looking at right now is an algebra 1 question, but it's also a geometry question. So I'm going to wait for a few moments for you all to try to answer this question. And I always like to drop a hint. If I see you're struggling with the question, I'm going to give you a hint so that you understand how to go about it. So I'm going to give the first hint for this question. Okay, 10 over 2. I need to have a final answer. What is 10 divided by 2? What is that going to give you? Okay, so let's go ahead with our first hint for this session. It's going to be slope is y2 minus y1 over x2 minus x1. So that's going to be your slope for any line that connects 2 points. So I see 1 over 5, I see 5, I see 5, okay. All right. So this was a topic we covered this week for Algebra 1. And like I said earlier, this is also a topic that you need in geometry. So this helps you in those 2 subjects. And I see there are a few answers already. So let's go ahead and look at it together and see how we would approach it. I've given you a hint, and the hint is the formula. So what I'm going to do here is it's good practice when you're learning. When you become an expert at this, you don't have to do this. But when you're learning, it's good to always have x1 here, x2, y1 here, and then y2. So now that we're going to apply the formula, we know exactly where our values are coming from. So our slope in this case is going to be y2, which is -3, minus y1. Sorry, this is x1, y1. Sorry, my bad. This is x2, y2. That's correct. So y2 is -3, and then y1, let me correct this actually. This is going to be x1, y1. This is going to be x2, y2. Okay, that's correct. So y2 is -3, y1 is -7. So it's -3 minus -7 divided by x2, which is 0, minus x1, -2. Did anyone do it this way? So now that you have your x1, y1, x2, y2, you've plugged this in. Now you can simplify the fraction that you have. So this becomes -3 when you have a negative outside the parenthesis and a negative right inside the parenthesis, this is going to become a plus 7 divided by 0, which is x2 minus x1. So this is 0 plus 2. Now we have negative 3 plus 7 is going to give you 4. Don't forget the rule. When you have different signs, you're going to subtract and then you're going to use the sign on the bigger number. So 7 minus 3 is 4. The sign on the bigger number is positive, so this is going to give us a positive sign divided by 2. So this is going to give us 2. So I see lots of 5s and 1 over 5. How did you guys come up with that? I would like to actually see. Make sure I'm not the one that made the error. I want you guys to show me what you did. You can just type it out in the chat. Just tell me what you did that got you to 5 or 1 over 5. Good afternoon, Price Music. How are you? If you're joining us on the channel, and also like this video and drop us a comment so we can know how to better serve your needs. Okay, so we have 2 on this. Does everyone agree with this answer? Do you have any questions about this, about the approach that we're using to get to the answer? Okay. No, Michelle, what I was responding to, someone said the answer is 10 over 2. I said you have to simplify whatever your answer is so that we get the most simplified answer, and he responded that 10 over 2 is 5. But I hadn't solved it together as a group. I just wanted him to go the extra mile to solve the question. Okay, let's go to the next one. If you have any questions as we go along, I'll be looking at the chat to make sure that I address your questions. So please go ahead and ask questions if you have them. So now we have, what is the value of b if 2 parenthesis b minus 3 plus 5 is equal to 5 parenthesis 3b minus 1. So we're trying to find the value of b. What is the value of b in this case? So let's give you some time to at least try to answer the question, and then we'll do it together. Let's see. Give it a try. Michelle is saying that for us to be able to solve this, we have to use the distributive property. So let's use the distribution or distributive property as our first start. Remember, everything you do in math starts with PEMDAS. Okay? Parenthesis always comes first. So whatever you have to do, you have to simplify or work with the parentheses, and that leads you to using the distribution property in this case. This topic you will find most likely in Algebra 1 or 8th grade. Some 7th graders may do it if they're in pre-AP. So if you're familiar with this is something you can do. I want you to still try it. You know, one of the things with math is you always need to make sure that you remind yourself of different topics along the way. So this is just a chance for you to also remind yourself about how to solve multi-step equations. So this is what we're trying to do here as well. So let's wait for a few more moments and then we'll see if anyone has the right answer, or if you need help, you're not sure how to solve this type of question, I want you to also feel free to say that. All right, so let's go ahead and get started with solving this question together. And if you have questions along the way, remember, you can always ask. So we're going to use what Michelle gave us a good guide, which is to start by using the distribution or the distributive property. So we're going to start with that. I'm going to first write out the question so I can work from my own question. So this is 2b minus 3 plus 5 equal to 5, 3b minus 1. Okay, so we're going to start with the distributive property. So we're going to multiply 2 by every term in the parentheses. So that's going to give me 2 multiplied by b. That should give me 2b. And then 2 multiplied by negative 3 should give me negative 6. And then we have here plus 5. This is going to be 5 multiplied by 3b. That is going to be 15b. And then 5 multiplied by negative 1 should give us negative 5. So now we're going to group common terms together. Let's simplify. On the left hand side, we have 2b minus 6 plus 5, negative 6 plus 5. Remember, when the signs are different, you're going to subtract. So 6 minus 5 is going to give us 1. And then when we look at 6 and 5, 6 is the larger number. The sign to the left of 6 is negative. So our answer is going to be a negative number, which is equal to 15b minus 5. So now we have to group common terms together. We have to isolate the variable, which simply means that we want to make sure that all the variables are on one side of the equation and all the non-variables, or we call them constants, are on the other side of the equation. Because you have an equation here, it doesn't matter what side you choose. So I'm going to choose the right-hand side for b because I have a bigger number there already. So let's go ahead and subtract 2b. I need to move it out of the left-hand side and I need to bring it over here. 2b here. So that's going to be negative 1 equal to 15b minus 2b is 13b. Then we have minus 5. And now I need to move the constant out of the right hand side. The only way to do that is to find the opposite of 5, of negative 5. That is going to give us positive 5, and then we're going to add that to both sides. When you have the equal to symbol, you have to remember that what you do on one side, you must also do on the other side. So now we're going to simplify this. Negative 1 plus 5, same rule we discussed earlier. Signs are different. We're going to subtract 5. We're going to subtract 1 from 5, which is going to give us 4. But then remember that the 5 is the larger number and it has a positive sign. So we're going to have plus 4 equal to 13b. So now we get to this point and we have to find the value of 1b. 13b is equal to 4. So we're going to just simply divide both sides by 13. So we divide both sides by 13 and we get our answer as b equal to 4 over 13. So that is the answer to this question. All right, good. Esther, you got good. So we got 4 over 13 for B. So thank you for your response on this. Thank you for the hint. And those who were able to answer it, thank you for at least for attempting it. And if you were not able to answer it, I hope you can now answer this type of problem. Otherwise, let me know. We can do another example together. I want to make sure that you understand this type of problems and you can do them on your own. Okay, let's go to the next question. The next question is a question on functions. This is an Algebra 1 topic. It's most likely going to be the first thing you learn in Algebra 1. And in some states, you may actually learn that towards the end of your 8th grade. So this is Algebra 1. We're going to create a function, a mapping diagram to help us tell if the points we're given represent a function. So we're going to draw up a mapping diagram. Let me give you an example of what a mapping diagram looks like. But before I do that, I want you to also think about the fact that to determine whether your points are part of a function, you need to find out the domain and the range of all of these points and see how they map to each other. So when you look at a function mapping diagram, here's simply what they're looking for. You have something that looks like this. You have another one. The one on the left-hand side usually implies your input, and the one on the right-hand side is for your output. So this is your input here. This is your output. And you need to remember that your input is your domain, your output is your range, and you have to create the mapping diagram. All right, Ini seems to have an answer. So it says they have repeating x values, so they cannot be a function. Okay, is it that they have repeating x values? What about the range? How does the range factor into that thought process? Your thought process is you're on the right path, but I want you to go a bit deeper. You have repeating x values. What about the range values to those x values? Let me go ahead and draw our circles because that's what we're going to be doing. Let's create ours right here and create another one right here. So for our domain and our range. So let's go here with our input, and this is going to be our output. So I see Esther says no, they cannot be part, they will not make a function. That is very interesting. That's a good response. They have repeating x values, so no. Okay, so I think we have some answers already. So let's go ahead and go into it a bit more. So we're going to start with the input. Your input is also known as your domain, and your output is also known as your range. So whenever you have a point has an x value and a y value. This is going to be your x value, your y value, x, y, x, y, x, y, x, y. Okay, so your domain also is your x value and your range is also your y value. So what we're going to do next is we're going to list out the domain values. So we have here -4 is one of them. We have 1, we have 6, we have 0. We have another 6, so we don't need to repeat it because we already have a 6 in the domain values. Now let's look at our range values. We have 7, we have 0, we have -3, we have 1, and then we have 5. So this is what you will do when you're setting up your mapping diagram. So you can see here that we've already captured every single point is captured in this mapping diagram. Now we have to create the links between the domain and the range. Now, how do we do that? You have to look at each of these points. So -4 domain has a range of 7. So we're going to create that link right there. Then we have 1 to 0. Okay, 1 to 0. Let's do it this way. We have 6 to -3. So we have 6 to -3. We have 0 to 1, 0 to 1. And then we have 6 to 5. We have 6 to 5. Now that is where the problem is. You cannot have the same domain value point to 2 different range values. When you have that, you don't have a function. So everyone who said we don't have a function is correct because we have a single domain value with 2 different range values. So does anyone have any questions about that? So whenever you see mapping diagrams, just think that this is what they're really looking for you to do. Okay, that's good so far. We're going to go to our first puzzle for the day right after this, but I want to give you a chance to ask questions. Please go ahead and ask any questions you may have. If there's anything we've covered so far that you are not sure of or you don't think you can do on your own, please feel free to ask the question and I will be glad to answer those questions for you. All right, let's go to the next. The next thing we're going to do here is our first puzzle. Okay, so this is our first puzzle. 12 plus 21 is 339. 13 plus 22 is 358. 41 plus 21 is 6215. 32 plus 15 is 4730. 24 plus 55 is what number? So let's go ahead and try this. I'll give you some time. Any basic logarithms? We can do some of that. We can do some of that. Yes, we can do some of that. Are you looking for the laws of logarithms, how we can use the laws, or you just give me some more? I mean, logarithms are very wide. I want to know exactly what area you want to get into. You just want an introduction? We can do something like that. So this is our first puzzle, and then after this puzzle, we'll try to answer the question on logarithms. Okay, no problem. I see. Thanks for that response. I will go into the laws of logarithms next. Okay. So I'm going to give you a slight hint on this one. You only need to add and multiply to get your answers here. You're going to add and multiply. So that's your hint. If you add and multiply, you will get your answer. Let's give you a few more moments on this, and then we'll try to see if we can come up with the algorithm for these sequences here. Again, if you're here today and you're not a subscriber yet, please go ahead and subscribe. We will be having we'll have a lot of interesting information for you. We also will have a lot of useful resources that you can use in your math learning, especially during the summer. We will be uploading new topics frequently most likely from about next week. We should start having maybe 1 or 2 main topics every week that you could use. Some weeks we may do more. So feel free to go ahead and subscribe. Our method is always the repeatable, process-driven approach to math. We want to make sure you understand the basics before you get to the top. Okay, I see 7945. Okay, that is okay. I'm going to take note of that because I think that's a very interesting answer. 7945. That is a very interesting answer. Let's give 1 or 2 more people a chance to try to answer this puzzle, and then we will go over to laws of logarithms. Does everyone else give up? You don't feel like you understand what to do? Remember, I give you the hint. All you need to do is add and multiply. Everything you need to do here is addition and multiplication. All right, so let me start by actually showing you the hint in 1 or 2 and see if you can get to your answer. So here we have, let's go ahead and add 12 and 21. That's going to give you 33. 1 plus 2 is 3. 2 plus 1 is 3. 3 multiplied by 3 gives you 9. Let's go to the next one. 13 plus 22 is going to give you, oh, this is this one is actually supposed to be 16. Sorry, supposed to be 16. So 1 plus 3 is 4. 2 plus 2 is 4. And that should give you 3, 5. And then it should give you 16 here. So you multiply, you get 16. And here you have 41 plus 21. That gives you 62. 4 plus 1 is 5. 2 plus 1 is 3. You multiply and you get 15. So the next one after that, you have 32 plus 15. You get 47. 3 plus 2 is 5. 1 plus 5 is 6. you multiply and you get 30. And so for our question here, 24 plus 55 is going to give us 79. Okay, 2 plus 4 is 6. 5 plus 5 is 10. So you multiply and you get 60. So you were really close. You were really close. You all are really close on that. Okay, Adeze, fantastic, wonderful job on that. So now we're going to, now that we have this is just a puzzle, something to kind of lighten the mood for you guys. What I'm going to do now is we're going to look at logarithms. I'm not going to go into a lot of detail. I'll start off by showing you some of the laws of logarithms and how logarithms tie back into exponents. So let's pull up a blank sheet here. So let's start with the exponent. Exponent, you have a to the power of b is equal to c. So the logarithms, you can look at it as the reverse of the exponents. And so what you have here is, if I had something like 2 to the power of 3 is equal to 8, then this simply means that log, our base is going to be the same, which is 2 of 8 is equal to 3. So you always have, let me draw some arrows to help you. 2 to the power of 3 is equal to 8. So that's kind of how you read it. This is your base. Remember, in your exponent, this is your base as well. 2 to the power of 3 is equal to 8. So that's really how you can create a relationship between logarithms and exponents. Now, what we're going to do, I know the question here is about the laws of exponents. There are a few laws that we can apply, but let's go ahead and do some addition, subtraction laws, and we'll see what else we can come up with. So let's look at laws of exponents. Laws of exponents. Oh, sorry, logarithms. Laws of logarithms. We have the addition law. The addition law simply states, that if I have the log of any number, let's make it a here, to the base a of a number p, plus the log to the base a of a number q. Take note of the fact that the bases have to be the same for you to apply any of these laws. The bases have to be the same. So this is going to be the same as the log to base a of p multiplied by q. This is the first law you'll most likely learn as you're working through logarithms. So log to base a of p plus log to base a of q is going to be the same as log to base a of p multiplied by q. Let's try an example together. So if I had log to base 3 of 5 plus log to base 3 of 8, this is going to be log to base 3 of 5 multiplied by 8, which is log to base 3 of 40. That's simply what the law states. The second law here is going to be the subtraction law, and you can see also that with the subtraction law you're going to have, let's try this, log to base a of p minus log to base a of q. This is going to give you log to base a of p divided by q. So you're going to have, for example, log to base 5 of 60 minus log to base 5 of 6. This is going to give you log to base 5 of 60 divided by 6, which is log to base 5 of 10. So this is another example. There are a few more that we can look at. Okay, there are a few more. Let's look at 2 more laws. Let's see. Maybe let's try 3 more laws, and then we should be good with an introduction to logarithms. And guess what? We have videos on the Math Is channel on these topics. There are quite a few that we go over, not just going over the laws, but we go through a few examples just so you can see how to apply them in various ways. If the bases are not the same, you cannot apply. If the bases are not the same, you can't apply these laws at all. It will not work. Now, there is a way to convert the bases. You can actually solve them, but that's going to take quite some time for me to walk through that within the time that we have left. So there's a video on the channel that actually goes through change of base. Whenever you have different bases, you have to change them to common bases before you can work with them. So let's go ahead, and I'm going to show you 3 more laws of logarithms, and I think those should kind of give you some ideas on how you can solve some more complex logarithm problems. So another one we have here is log to base a of a is equal to 1. Remember what I showed you earlier about logarithms and exponents? You start a to the power of 1 is equal to a. That's simply how, that's your cycle of exponents and logarithms. That's kind of how they relate to each other. So this is a common law. So example is log to base 5 of 5 is equal to 1. So this is common. You may get asked this as well. And then we have another one here. It is log to base a of p to the power of m. This is going to give you m log to base a of p. So if I had an example like log to base 2 of 5 to the 3rd power, this is going to give me, I'm going to move the 3 out here to the left. So it's going to be 3 log to base 2 of 5. And the final one we're going to be looking at is log to base m of 0 is equal to, actually of 1 is equal to 0. Of 1 is equal to 0. And let's show you the cycle again. Any number to the power of 0 is going to give you 1. So it doesn't matter what the number is, as long as you have log to base 125 of 1 is going to give you 0. As long as you have, whenever you have a base, as long as you're trying to find the log of 1, you're always going to end up with 0. So does anyone have any questions on this? Did this, Mofe, did this help you? Did this kind of at least give you something to start with? Because to get this, you're going to have to walk through several examples. And did this help you as at least give you a starting point? Okay, thank you. Thanks for the feedback on that. Okay, now we're going to a topic on geometry. This is a geometry topic. So M is a point between P and Q. If PM is equal to 3x plus 5 and MQ is equal to 6x plus 11, what is the value of x if PQ is equal to 61? All right, thanks Esther for the affirmation. Thank you for that. Yeah, watch the videos, and if you have any questions, feel free to leave a comment on the videos actually, so that if there's anything that is not clear, we can actually correspond, or you can also contact us directly, and then we'll try to answer questions for you as well. Okay, so we have M is a point between P and Q. PM is 3x plus 5. MQ is 6x plus 11. What is the value of x if PQ is equal to 61? So we want to find out the value of x. We have some line segments. This is an introductory part of geometry. So if you're about to get into your geometry class, this is something that you should at least have an understanding of how to interpret. These are the types of questions you will get asked, and this here allows you to combine your knowledge of algebra and your knowledge of geometry to solve important questions. So what I always like to do when you have something like this, I would encourage you to do this. Try to, the more you can show it, some of us are pictorial learners, we have to see. We're visual learners, we have to see it for it to make a lot of sense. P over here, we have Q over here, and we have M right here. Let's make this M is right here. So here we're saying that this is going to be 3x plus 5. This is going to be 6x plus 11. And all of this, let's go with these arrows here, these arrows here, all of that is going to be 61 units. So that is going to give us 61 units. The answer is 5, says Terence. Wonderful. So let's wait for a few more people to answer the question, and then we'll try to solve it together. So those of you in geometry right now or going to geometry, this should be something that, get familiar with this type of questions. You will most likely see it in your first grading period of your next school year. Okay, so let's go ahead and try to answer this question together. So what we're going to be looking at here is that PM plus MQ is going to give us PQ. So we're going to, now that we have this statement, we're going to substitute values in. So we have PM is 3x plus 5. So we have 3x plus 5 plus 6x plus 11 is equal to 61. And so let's go ahead and add numbers together. We have, let's group common terms together. So we have 3x plus 6x plus 5 plus 11 is equal to 61. And we're going to have 9x plus 16 equal to 61. Now we can subtract. We can now isolate x. To isolate x, we're going to move the non-variable term out of the same side as x, or we can say we're moving the constant away from the same side as x. So we're going to subtract 16 because that is the opposite of 16. It's negative 16, so we're going to subtract 16 from both sides. So 9x is going to give us 45. And then now to completely isolate x, we're going to divide both sides by 9. And so x is equal to 5. So that is, okay, x equal to 5, wonderful. So we got that answer already. Now we're going to do something a little bit interesting. Okay, Algebra 2. This is mostly for Algebra 2 students. You can do this in Algebra 1 if you're familiar with it. Anyone should actually be able to attempt this. But right now, I know that this is a topic that is heavily covered in the Algebra 2 curriculum. So feel free to attempt this, and if you're not sure how to do this, we will go through it together. What we're going to do here is we're going to find the values of x, and we're going to try to represent those values on the number line. We're going to represent these values on the number line. So give it a try. Everyone should give it a try. This topic is absolute value inequalities. We're trying to solve absolute value inequalities. They are linear inequalities, which simply means you'll make up a line, a straight line. So x equal to 3. X is going to be, it's because it's an inequality, x is going to not just be equal to one value, it's going to be a range of values. That's what the inequality stands for. It means that it's not one specific value, but you have a range of values. So take a look at it one more time and you should be able to see where your range falls in. We're looking for a range of values. I'm going to show you 2 different methods to do it, just so that you can see that there are different ways to get to your answer. I'll show you 2 different methods and then you can pick whatever method you like and use it. So x is 12, x is 3. That's interesting. Don't forget, it's a range of values. It cannot be just one answer or just 2 answers. It's a range of values. There are so many values that make this correct. So you have to look at the range. So I think everyone it seems like we have a few people that are able to solve this. So let's take one step forward toward it. Let me give you one method that this was a topic we actually covered in the summer program last week. And I showed the group 2 different methods. So I'm going to show you one of the methods that everyone seemed to enjoy using. So let's go ahead with that. I'm going to try with that method first. So we're going to have 2x minus 3 less than equal to 9. Then we're going to have a less than equal to and put a negative 9 here. So let's start from there. So you're going to solve here for x. Let's see if that rings a bell, helps everyone remember. I'm actually going to create a video on this method so that I have the other method I'm going to use is one that I use more often, but this is also a very good method. So I'm going to create a video to help you all get familiar with this method, and I'm going to show lots of examples just so that you can see how to apply this in various questions. So negative 3 less than x less than 4. All right, that sounds reasonable. Less than 4. It's less than equal to, okay, less than 4. Okay, let's take it one step forward. We're going to add 3 to everything because this is a negative 3 here. We are going to find the opposite of negative 3, which is positive 3. Let's go ahead and add that to every single side of this inequality. So we have, now we can simplify this. Negative 9 plus 3, we're going to have negative 6 less than equal to 2x less than equal to 12. So now we have to simplify. All right, that sounds good. Okay, you meant 6, not 4. That's perfect. So now we are going to divide by 2. We're going to divide every side of the inequality by 2. And we have negative 3 less than equal to x less than equal to 6. So now there's a different method. I just found that this is a more direct method. It's easier to use. But there's a different method, which is having, because when you have an absolute value, the absolute value of a negative number, negative 6, is 6. Also, the absolute value of 6 is going to give you 6. So you have 2 different scenarios or 2 different cases in this question. You have plus 2x minus 3 less than equal to 9. You also have negative 2x minus 3 less than equal to 9. If you solve these inequalities, you will actually get to this point. Does anyone want me to show how to solve the inequality using that method, or are you okay with just getting used to the method being used already? If you want us to go into a bit more detail showing you this other method, I don't have a problem doing that. But this is a method that I just found students to enjoy using. It's pretty straightforward. You don't have to do a whole lot. Okay, so now we're going to represent this on the number line. So let's go ahead and draw our number line. Let's go with a black color on this one. Number line here. Our number line is going to look like this. Okay, so this is what our number line is going to look like. We have negative, let's put a 0 here. 0, let's make our -3 here, and let's make our 6 right about here. So we're saying that we have less than equal to, so we're going to have a shaded circle here, and then we're also going to have a shaded circle right about here. So we're simply saying here that -3 is less than x, which is also less than 6, which simply means that our range of values is going to be from -3 to 6. So that's simply what this is. So we're going to have all values from -3 to 6. And one of the benefits of using the inequality is because we have so many values in here, it's a mistake to think that we have just 9 values, because from -3 to 0 is 3 units, and from 0 to 6 is 6 units. We don't have 9 values. We have an infinite number of values here, and that's why you have your inequality expressing a range of values. Does anyone have any questions? Okay, can I show how to do it the other way? All right, I will do that. Let me actually get a new page and put this on a new page so that you can see how to do it the other way. Okay, so let's get a new page. So we have positive 2x minus 3 is less than equal to 9, and we have negative 2x minus 3 is less than equal to 9. So now that we have positive, we have 2x minus 3 is less than equal to 9. So we're going to add 3 to both sides. Add 3, add 3. So 2x is less than equal to 12. And now we can divide both sides by 2. And x is less than equal to 6. Now we come over to this side. We're going to distribute the negative sign. So we have negative 2x plus 3 is less than equal to 9. And we're going to subtract 3 from both sides. And you have negative 2x is less than equal to 6. Now we're going to divide by negative 2 because we need to isolate x. So we divide by negative 2. Divide by negative 2. So we have x right here. We have 6 divided by negative 2. That's going to give us negative 3. But because we are dividing by a negative number, we have to switch the symbol, the inequality symbol, to greater than equal to negative 3. So now what you have here is that you have x. Let's draw a number line here. We have 0 here, and we have 6. We have negative 3. So here we have x is greater than equal to negative 3. So we have this right here. X is greater than or equal to negative 3. We also have x is less than 6. So let's start from here. So let's do this. We can go straight here. Let's keep going, maybe 8 over here. So let's keep going right here. And then we have x is greater than, so we have x greater than equal to negative 3. Then we have x is less than equal to 6. So we start from 6 right here. And then we have x is less than equal to in that direction. So what I'm going to do here is I'm going to shade in the opposite direction right up to here. and we can keep going in that direction because we have x is less than or equal to -6. Now, when you have a cross matching, it's going to give you your region that satisfies this inequality. Can you see that your region here is from -3 all the way to 6? So this is going to be -3 less than or equal to x less than or equal to 6. Now, some students don't like this because there's an additional, you have to do additional manipulation of your number line, and some don't feel comfortable with it. And that is why a lot of students tend to like this method, because it's more direct. So is there any questions about these two methods? Feel free to ask questions. We're just about done with topics. I had some other topics I wanted to cover, but I'm actually more satisfied that I answered your questions. So Adeze, did this help you? Do you understand it better? This method, actually, a lot of the videos I've done on inequalities uses this method here. Let me see. Yes, a lot of the topics and the examples that I've used in the videos on the channel will use this method. I'm actually going to create more videos that would use this method. I like this method, and I think most students like it. So I'm going to do something that helps with this, with understanding how to use this method. All right, does anyone have anything else? Actually, before we go, we have a few more minutes. We have 2 more minutes. I'm going to do our last puzzle. I think it's an interesting one. Let's do... Okay, so this is our last puzzle. We have like a minute. I think it should be enough to find the 5 mistakes in this. Can you find 5 mistakes? One more puzzle. 5 mistakes. We're going to find 5 mistakes in this list of numbers and their spellings. We're looking for 5 mistakes. Anyone come up with any of the mistakes yet? I know it's spelling, and it's spelling, and it should be, oh, this shouldn't be a big deal. Let's see the 5. Okay, I'm waiting to hear what the 5 are. 5, 6, 5, 6, 7, and 1. Okay, the 6. All right. 1, 5, 6, 7. Okay. 1, 5, 6, 7, 5, 6, 7, and 1. Wonderful. So looks like everyone is onto it. So that's good. So we got this right here. This should be a 1, not an I. This should be F right here. This should be an I6. This should be S, E. So those are the... That's good. Everyone is done well. So thank you all today. This was fun. This was exciting for me. I enjoyed answering your questions. I enjoyed watching you all think through the problems that, that I brought through. And also I enjoyed you asking me to do something that was outside what I planned to do. Always a good challenge for me to stay prepared. And so thank you all for your time. And I really appreciate you guys coming to join me for an hour on Thursdays. Always remember, on Tuesdays, we also have something that allows you to refresh your memory on stuff that you probably did 5, 6 years ago in maybe 2nd grade or 3rd grade. Sometimes we forget this stuff, so please join us on Tuesdays. If you have younger siblings that, could benefit from this as well, ask them to join us. Looking forward to hanging out with you guys again next week. Enjoy your weekend and be blessed. Thank you again. Thank you. Also, if you've been joining us and you have not subscribed yet, what are you waiting for? I think we have some good content that's helping you with your learning. So please go ahead and subscribe and just share the message. Share the message with your friends, family members. You may even know parents that are struggling with their children understanding math and they don't know where to go, or maybe they can't even afford to go somewhere to get help. We have resources that could be helpful to them. Please go ahead and spread the word, spread the message, and thank you again for your support. Look forward to hanging out with you next week. Be blessed. Enjoy your weekend.